DeepSeek-R1 has created such a buzz overnight. Everyone's talking about it. But what's the big deal, and why should you care? Hi everyone, welcome back to my channel, where we dive into all things machine learning and MLE careers. I am Perceptron Prime. I have a bachelor's degree in computer science and a PhD degree in ML, and I now work as MLE at one of the fan companies. Subscribe to my channel for more tutorials, news, insights, and career tips tailored for machine learning engineers. DeepSeek-R1 is an LLM trained with reinforcement learning, or RL, and boasts exceptional reasoning capabilities. It is open-sourced and builds on the base model DeepSeek v3. There's a 50-page technical report on v3 that has been released, which I will cover in another video. As for R1, there's a much shorter technical report, and it just dropped yesterday, and it already garnered significant attention. Now, before we dive into the significance and implications of R1, it's important to first understand reinforcement learning and its role in training LLMs. In LLM training, there are two main stages: pre-training and post-training. Pre-training involves training the model on massive amounts of data, often at the scale of terabytes, and this stage is used to acquire basic knowledge. However, this stage doesn't specialize the model in tasks like reasoning, which is why post-training is necessary. Post-training typically starts with the supervised fine-tuning phase, where the base model is refined using smaller-scale, high-quality label data. Following SFT, there is a stage aimed at better aligning the model with human preferences, and that's where RL, or reinforcement learning, comes into play. Reinforcement learning is a machine learning approach where an agent learns to take actions in an environment to maximize the cumulative rewards. A reinforcement learning framework has a few key components. The actor, or the policy, is a model that can generate actions based on the current state. And then there's a critic that evaluates the quality of the actor's actions. And environment represents the feedback mechanisms such as human evaluations or automated metrics assessing the model's outputs. And then there's a reward. Reward quantifies the quality of an output. And rewards can come from human ratings or models trained to predict human preferences. So in the context of LM, the actor is just the LM itself that makes text outputs, based on the current state, which is the text context so far. The reward can come from human ratings. So, for example, OpenAI may hire human annotators to rate the answers and give a score on how good the answers are. And the critic might be implemented as a neural network that learns to approximate reward signals from the environment. In methods like DPO, the critic is bypassed, with the reward signal directly guiding policy updates. Why is RL needed in post-training? Well, because supervised fine-tuning, or SFT, trains models on label data, teaching them to mimic human demonstrations. However, this limits the model to existing data patterns and may not fully capture human values or some nuanced preferences. Reinforcement learning mirrors how humans or animals learn naturally, discovering solutions through exploration and adaptation rather than imitation. It enables models to improve based on dynamic, real-world feedback rather than static datasets. And it is crucial for tasks requiring optimization beyond what supervised data can provide. Reinforcement learning can also trigger emergent behaviors. So it can encourage behaviors like self-reflection or exploration, helping models improve performance in diverse scenarios. So to conclude, by combining supervised fine-tuning for foundational capabilities and RL for alignment and optimization, we can achieve a balance of functionality, alignment with human values, and task-specific performance. So why is DeepSeek's new release such a big deal? First, DeepSeek showed that it is possible to bypass SFT and start with RL directly. And this is called code start, meaning the model does not rely on human supervision or pre-existing labeled data. In their report, they mentioned that their R10 model, purely RL-driven, already demonstrates remarkable reasoning capabilities. However, it encounters challenges such as poor readability and language mixing, so they explored another training paradigm, which is to incorporate multi-stage training and cold start data before RL. This leads to DeepSeek-R1, which surpassed OpenAI's O1 across multiple benchmarks that requires reasoning. The fact that cold start works in the first place is super impressive, because this cold start strategy mirrors the methodology of AlphaZero, which mastered games like Go from scratch without first learning from the moves of human grandmasters. This demonstrates the power of RL in learning complex strategies autonomously. And it's for sure DeepSeek's most groundbreaking contribution. And you may ask, is code start really such a big deal? Yes, because a code start in reinforcement learning is significant because it demonstrates the true autonomy of an AI system. Unlike models trained with human supervision, code start models begin with no prior knowledge at all. They learn entirely from scratch, relying solely on trial and error, guided only by feedback from the environment. This is essentially how humans or animals learn naturally, discovering solutions through exploration. For example, AlphaZero, one of the most famous CodeStar systems, mastered games like chess and Go without studying human strategies. What's really cool about this is that it allows models to uncover novel strategies or behaviors that humans might never think of. Finally, cold start training removes the dependency on labeled datasets, which are often expensive and time-consuming to create, making this approach highly scalable for new or unexplored domains. So, DeepSeek just marked a milestone for creating LLMs with amazing reasoning capabilities without predefined guidance. How impressive is that? I can't wait to see what follows next. Let's watch DeepSeek together. If you like this video, give this video a like and don't forget to subscribe for more machine learning tips and career advice. Comment below if you have questions or want me to cover a specific topic next. Thank you for watching and see you in the next one.